Welcome to Ask and Learn.
So given in the question, Newton's law of gravitation says that the magnitude of force F exerted by a body of mass small m on a body of mass capital M is given by the relation F that is equal to capital G small m capital M by r square, where G is the gravitational constant and r is the distance between the bodies. And it has been asked to find first the rate at which this force changes with the change in the separation between the two masses, that is dF by dr, and to explain its meaning. In the second part, it is given that if the earth attracts an object with a force that decreases by a rate dF, that decreases by a rate 2 newtons per kilometer when r is 20,000 kilometers. That means dF by dr at r equal to 20,000 kilometers is given to be minus 2 Newton per kilometers. And it has been asked to find the value of the rate at which this force changes at r equal to 10,000 kilometers. Now, according to Newton's law of gravitation, the magnitude of force between the two masses, the two bodies of mass small m and capital M separated by a distance small r, is given as capital F, that is equal to gmm by r square. So, taking its derivative with respect to r in order to find the rate at which this force changes with respect to r, g small m and capital M are constant. So we take the derivative of 1 by r square with respect to r, which comes out to be minus 2 by r cube. Finally, df by dr comes out to be minus 2 gm capital M divided by r cube. Since this df by dr is less than 0, the force of attraction decreases with the increase in the separation between the bodies. And this between the two masses, and it decreases at a rate proportional to 1 by r cube. This is the answer to the first part of the question. In the second part of the question, it is given df by dr at r equal to 20,000 kilometers to be equal to minus 2 Newton per kilometer. Now we know df by dr is minus 2 g small m capital M divided by r cube. We put r equal to 20,000 kilometer here, and we do a little bit of simplification. We get a value for capital G times small m times capital M, which is 2 cube into 10 to the power 12, that is 8 into 10 to the power 12 Newton kilometer square. Let it be equation number 1. At r equal to 10,000 kilometer, we put in the same expression for df by dr, we put r to be equal to 10,000, and now we have the value of gmm. So putting the value of gmm from equation 1, we get df by dr at r equal to, or when r is equal to 10,000 kilometer, to be equal to minus 16 Newton per kilometer. Thus, the force decreases at a rate of 16 newtons per kilometer when r is 10,000 kilometers. Thank you.